Rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. And the book here is Mathematics for IIT-JEE Main and Advanced by ML Khanna sir. And I'm Subuh Nadeem presenting you the videos of the concerned chapter here. So the chapter which we are discussing here is chapter number 24, which is of volume 2 of the book. It is addition of vectors. Now if we talk about here some of the important theories. So what are those important theories here? Let us see. First of all, we have in addition of vectors, a vector A which is added to a vector B is actually a resultant vector. So this is a vector A, and on the head of the vector A, the tail of the vector B is being placed, and then there is a resultant vector from the tail of the A to the head of the B. So this resultant vector is actually A plus B vector. So this is first we have to understand. This is also called triangle law of addition of vectors. Similarly, we have parallelogram law of addition of vectors, that if this is a vector A, this is a vector B, and we complete a parallelogram. How do we complete a parallelogram? We make other sides also like this, and then the diagonal of the parallelogram is called the addition of A and B. Or in case of triangle law, the third side of the triangle is the addition of A and B. So we have two ways in which we can write the addition of vector: triangle law of addition of vectors, and another one is parallelogram law of addition of vectors. In triangle law, as we can see, we have the resultant as the third side of the triangle, and parallelogram law we have the diagonal. Further, if we have, suppose, orthogonal system, then orthogonal system is taken as x-axis, y-axis and z-axis. The z-axis is protruding outside of the plane of this board, and then we have this direction has a unit vector I cap. What is a unit vector? Whose magnitude is 1. In this direction there is a unit vector j cap. In this direction there is a unit vector k cap, and here there is a origin. So we write any point in the space as x comma y comma z in terms of these unit vectors as OP vector is equal to xi cap plus yj cap plus zk cap. Okay, now we have something called collinearity and coplanarity. So if we talk about collinearity, so collinearity is basically if we have two vectors which are collinear. So if there is a vector A and a vector B, and we say that these are collinear vectors, that means they lie on a same line, then what happens? We can write A as lambda B always, where lambda is some scalar. So where lambda is a scalar, because we know that the direction is same, there may be only difference of magnitude or they may be anti-parallel. So lambda can be negative in case of anti-parallel, and in magnitude having different value, lambda can have different value, but the direction of A and lambda B will be same. Now if we say that points are collinear, here vectors are collinear, if we say points are collinear, suppose there are 3 points A, B and C, and we say that these points are collinear, then it means that the vector formed by these 2 points B minus A and the vector formed by these 2 points C minus B is actually B minus A is equal to lambda C minus B. So the same result is there, only there is that we have the vector which is the position vector's difference. So we can also understand one thing over here, that if we talk about AB vector, then it is equal to position vector of B minus position vector of A. So this is from the result of addition of vectors only. What about coplanarity? So if we talk about coplanarity, there is a result which says that if we have three vectors which are coplanar vectors, then it means that any one of the vector, suppose A, is the linear combination of other two vectors because they are lying on the same plane. So we can always express a vector A in terms of the two other vectors B and C on that plane. Next, we have the important point here is equation of line. So if we talk about equation of line in vectors form, so it is actually if there is a point A through which the line is passing and there is a direction B in which it is passing, so we say always that the position vector R on that line is R is equal to A plus lambda B. So A is the point through which the line is passing and B is the vector in the direction of the line. Another form is equation of a line. If suppose we have instead of this 2 points on the line given, that is A and B, these are the 2 points given, then R can be written as A plus lambda, and the direction now is actually not B but B minus A. That is difference of these two position vectors. So this is B minus A. So in this situation it would be something like this. So I hope you understood the difference. Here B is the point on the line, here B is the direction of the line. Next we may have equation of a plane. The equation of a plane, when we write, we have something like this, that we have a plane on which a point is given. Suppose a point is given on the plane whose position vector is A and the normal to the vector n is given. Then any point on that plane with position vector R can be written like this with this formula, that R minus A is equal to, as you can see clearly here, that R minus A is a vector on this plane and the vector on this plane is actually perpendicular to the normal vector to this plane. So you can always say that R minus A, when you take the dot product with n here, that is the normal to the plane, what will happen? You will get as 0 because the angle is 90°. So you can say R dot n here is equal to A dot n. So this is the equation of the plane in this form. So these are some of the results which will be helpful for solving other problems in this chapter, which we'll see now. So if we talk about the problems, here there is a problem which says that ABCD is a parallelogram, P and Q are the midpoints of the sides AB and BC respectively. Prove that DP and AC meet in a common point of trisection, and similarly DQ and AC. So what it says, that we have a parallelogram ABCD like this, and further it is saying P and Q are the midpoints of the side AB and BC. So here there is P, here there is Q. Prove that DP and AC meet in a common point. So DP is there and AC is there. So they are meeting in a common point of trisection, and similarly DQ and AC. So DQ is this one and AC is this one. So similar result is for DQ also. So this one. So it says, now it is clear that after taking it, these are the midpoints. This is equal to this and this is equal to this, right? DP and AC meet in a common point of trisection, and similarly DQ and AC. So let us suppose that this point is R and this point is S, and if we want to say that they are meeting in a common point of trisection, So let us suppose that this is origin, the position vector of A. This is the position vector A, and this is having position vector B, and this is obviously having position vector A plus B. So now let us also see some of the other results, like P is A by 2 having position vector as it is the midpoint, and this will be A plus B by 2 as the position vector. Right. So this is how we can write it. Next we have the position vector of R, which we have to see. So if we talk about the vector dp and the vector AC, so vector AC is a line, and that can be written as AC can be written as R is equal to 0 plus mu A plus B, like this. Similarly, if we talk about dp, so if we talk about dp, it can be written as R is equal to A by 2 plus lambda difference of these coordinates, that is B minus A by 2. So this is how we can write it. Now they are meeting at some point, so we can just equate these two. So we can get mu A plus B is equal to A by 2 plus lambda B minus A by 2. Now if you are equating the coefficient of A, you are getting mu here, and here you are getting half minus lambda by 2. And if you are equating coefficient of B, it is mu here and it is lambda here. So finally, if you put the value of mu is equal to lambda here, you will get 3 mu by 2 is equal to 1 by 2. So mu is equal to 1 by 3, right? And lambda will also be equal to 1 by 3 on solving them. So you can easily see that the R position vector of this capital R is actually equal to 1 by 3 of A plus B, right? So what does it mean 1 by 3 of A plus B? Since from A to C it is A plus B, and you are taking A to R as 1 by 3 of A plus B. So this is the trisection point. This is 1 by 3. Similarly, if you talk about S, you can also prove that this is 2 by 3. In that case, you will take the equation AC and equation DQ. So similarly, you can do that also. So this is how we approach this question. Let us move on to the next question. The next question says, if A, B, C are the position vectors of the vertices of an equilateral triangle whose orthocenter is at the origin, then prove that A plus B plus C equal to 0. So this question is not a very big question. Here it is saying that it is an equilateral triangle. Now in case of an equilateral triangle, we already know that centroid and orthocenter and circumcenter and incenter, all these points coincide. So if you are talking about orthocenter, this will be same as centroid, because this is an equilateral triangle. And as the orthocenter is the origin, so we can say that centroid is also the origin. And what is the coordinate of centroid? So it is A plus B plus C by 3. So it will be equal to 0. So we can say that A plus B plus C is equal to 0. So we can finally come to this result. So it is not a very big question, it is a small question, just some concepts are required. Let us come to the next question. The vectors AB is equal to 3i plus 4k and AC is equal to 5i minus 2j plus 4k are the sides of a triangle ABC, right? So there is a side AB, there is a side AC. The length of the median through A is, so if we take this triangle ABC and the median through A is being asked, this is the midpoint, and AB is 3i plus 4k we have, so this is 3i plus 4k, and AC is equal to 5i, this is the direction, and here this is the direction. 5i minus 2j plus 4k, like this. Now you have to find the length of the median. So what you can do is, you can first find the resultant vector, this BC. So can you say that BC vector is equal to C position vector minus B position vector, or you can say AC minus AB, because BC plus AB is equal to AC by addition law of triangle. So if you do AC minus AB, what will happen? 5i minus 3i will be 2i, and then we have minus 2i minus 2j, and then we have 4k minus 4k, that will be 0. So this is what we are getting here. Now this is the vector BC. Can you tell what is BD? So BD vector is actually half of BC, because the D is the midpoint of BC. So this will be I minus j, half of this. Now if this is I minus j, then can you find the resultant vector AD? Of course, the AD resultant vector is equal to this vector AD is AB plus BD. This is AB plus BD, again by triangle law. So this will be 3i plus 4k and I minus j. So this will become 4i, and then we have minus j, and then we have 4k. So this will be 4i minus j plus 4k. Now this is AD vector. What is the magnitude of AD vector? That is the length of the median. So that magnitude will be found out by the formula root over a square plus b square plus c square. So it will be 16 plus 16, 32 plus 1, 33. So we are getting a square root of 33. So yes, our option is correct option C. Let us move on to the next question. Two forces act at the vertex A of a quadrilateral ABCD represented by AB, AD. So there is a quadrilateral here, and this is having vertices at ABCD, and two forces at the vertex A of a quadrilateral ABCD represented by AB, AD. So AB is like this and AD is like this. So they are acting at the vertex A, and at C, two at C represented by CBCD. So CB is like this and CD is like this. So these are acting on this point C. Prove that the resultant is represented by 4EF. Now it is being asked that their resultant is represented by 4EF. And what is EF? E and F are the middle points of AC and BD respectively. So this is your AC, this is your BD, and E and F, this is the midpoint of ACE, and F is the midpoint of BD, and you have joined them. So you have basically 4EF as the resultant. So you can say that you have to prove that AB plus AD and then plus CB plus CD is equal to 4EF. This is what we have to prove here. So now we have to do few constructions here which will help us in solving them. So what we will do here is, let us join AF and CF. So when we join AF and CF, what would happen? We have this triangle, and in this triangle E is the midpoint of this side AC. So we can always say that AF plus CF is equal to 2 times of EF. This is a result which we know earlier, that in a triangle, if we take two sides and their resultant, then that is twice of the median EF. If you want, you can prove this result. It is not too difficult. Let us take here that we have a triangle here, and in this triangle ABC, I am proving this result, that if there is a median AD, then we have this vector BA, this vector CA. So what we are doing here is, we are saying that this is equal to 2 times of DA. So in order to prove this, we will first find this vector, and this vector will be the vector AC. Actually this is CA vector. So CA vector minus DA vector. This is how we can write it, because DA plus CD is equal to CA. Similarly, if you talk about this vector would be BA vector minus DA vector, like this, because we know that DA vector plus BD vector is equal to BA vector, right? So I hope you are understanding this diagram. So as it is quite clear from the diagram that this is BA, this is CA, and this is BA minus DA, this is CA minus DA, and this is DA vector. Now since we know that this is the median, so this is equal to this. So these two vectors are actually anti-parallel, and we can say that CA is minus DA is equal to minus of BA minus DA. We can write it like this because their magnitude is same, both are same magnitude but opposite direction. So from here we get CA plus BA is equal to 2DA. So this is the result which I am trying to explain you, that this vector plus this vector is twice of this vector. So this result can be applied in this triangle, which is the triangle here, triangle AFC. So this vector AF plus CF is twice of EF. Now after applying this result here, you can also say that this AF is also for this triangle ABD. If you talk about in this triangle ABD, this F is the median because F is the midpoint here. So we can also say that AB plus AD, this AB plus AD is actually equal to twice of AF. So this will be twice of AF. We can write it like this. Okay. Similarly, we can say in this triangle DCB, we are talking about, that if we have this CF as the median of triangle DCB, then CB plus CD is equal to twice of, this is point C, right? Twice of CF. This is twice of CF. So we have three results here which we have to highlight actually. One is this result, another one is this result, and third one is this result. And all of these results have come from this result which I have proved here. You can also remember this as a final result and you can use in questions. So if we talk about AB plus AD plus CB plus CD, so that will be 2AF plus CF. And what is AF plus CF? That is 2EF. So finally you will get 4EF. So you have to use these three equations and you will come to the result. Now let us come to another question here. Prove that the straight line joining the midpoints of two non-parallel sides of a trapezium is parallel to the parallel sides and half of their sum. So what it is saying, two non-parallel sides of a trapezium are there and we have to join the midpoints of those. So this is A, this is B, and we have joined them, and it is parallel to the parallel sides and half of their sum. So these are the parallel sides of the trapezium. So we can always say that suppose this is a trapezium PQRS, and we can take this point as origin. This point is position vector q, this as position vector r, and then let us take this as position vector s instead of that, not r. So that will be in sync with the point, and this has position vector r. So now we know that r minus s is parallel to q vector. Now this AB vector, so this is the midpoint, so A vector can be written as s by 2, and this B vector can be written as r plus q by 2. So if we talk about AB vector, this AB vector is equal to q plus r by 2, this thing, minus s by 2. So this will be q plus r minus s by 2. Now if we talk about the sum of these two vectors, so that will be q plus sum of these two vectors, so that will be r plus s, r minus s, this vector is r minus s, and this vector is q. So we can always say that r minus s is ps, r minus s is rs, and this q vector is pq by 2. So this is the resultant vector AB, which is actually half of the sum of these two vectors. So we can say that it is parallel to the parallel sides because both are parallel to each other, so it will be parallel to AB also, and half of their sum. So here, from here we can find the resultant. The vectors A and B are non-collinear. Find for what values of x the vectors C and D are collinear. So if we have to find that these two vectors are collinear, so do you remember what was the condition? That this vector x minus 2a plus b is equal to lambda times this vector d, which is 2x plus 1 a minus lambda b, like this. Now if you equate the coefficient of a, that will be x minus 2, and here it will be lambda 2x plus 1, and if you equate the coefficient of b, there it will be 1, here it will be minus lambda, like this. Now from here you get lambda is equal to minus 1, so x minus 2 is equal to minus 2x plus 1 you will get. So from here you will get 3x is equal to 2 minus 1, 1, so x is equal to 1 by 3. So you can say that the answer for x is equal to 1 by 3. So here it is direct application of the theory which we studied little while ago. Let us see the next question. Points D, E, F divide the sides BC, CA and AB of a triangle respectively in the ratio 2:3, 1:2 and 3:1. Prove that the lines AD, BE and CF are concurrent and find the position vector of the point of concurrency. So we have triangle ABC. Point D divides BC in the ratio 2:3. So D is here, it is dividing it in the ratio 2:3. CA in the ratio 1:2. E is dividing CA in the ratio 1:2. And F is dividing AB in the ratio 3:1. Like this. Prove that the lines AD, BE and CF. So the lines AD, BE and CF, this is AD, this is BE and this is CF. These are concurrent. And find the position vector of the point of concurrency, this point. This point is P. So what we have to do here again, let us take that A is the origin and this C will become, suppose C by C position vector and B will be B position vector. So what will be E? E will be 2C by 3 bisection formula. And what will be F? This will be 3B by 4. And what will be D? So D will be 2C plus 3B by 5, like this. Now if you talk about the concurrency of the point P, so let us take the line FC. So what will be the line FC? FC will be the line which will be R is equal to C plus lambda 3b by 4 minus C, like this. Okay, the equation of a straight line when point and 2 points are given. And let us take the line EB. So if we take EB, R will be equal to B plus mu, and this will become 2C by 3 minus B. Now let us equate them. So when we equate them, and we will equate this one with this one and also equate the coefficients of C and B, what we will get. So I am writing the resultant equation. Coefficient of C will be from here 1 minus lambda, and coefficient of C from here will be 2 mu by 3, right? And what about coefficient of B? Here it will be 3 lambda by 4, and here it will be 1 minus mu, like this. So 3 lambda by 4 and 1 minus mu. So when we solve them, so from here we get 3 minus 3 lambda is equal to 2 mu, and from here we get 3 lambda is equal to 4 minus 4 mu. Now if you multiply this with 2 and add both of them, so what we will get is 6 minus 6 lambda plus 3 lambda, that will be 6 minus 3 lambda, and here it will be 4 mu minus 4 mu cancel, 4. So 3 lambda is equal to 2, lambda is equal to 2 by 3. Similarly, if you get mu, what do you get mu as? So from here you put lambda is equal to 2 by 3, so this will become 1 by 2, mu is equal to 1 by 2. So what we are getting here is, we can finally write, I am erasing this lower portion because we have got the value of lambda and mu. So as we have lambda, lambda is equal to 2 by 3 and mu is equal to 1 by 2. So I am writing it. And now I am erasing this portion where we have done the calculation part. How did we calculated it? I hope it is clear. We have equated the R of both the lines, because for intersection the position vector of the point of intersection will be same. And then since B and C are non-collinear vectors, we have equated the coefficients of B and C. Now what we have to do is, we have to check for the third line. Third line is BE. So is this a point of concurrency? So if this is a point of concurrency, then this position vector which we are getting here, when you can solve this one or this one, any one of them, you get as C minus 2C by 3, which will be C by 3, and plus B by 2. So this is a position vector of P, the intersection of FC and EB. Now if this is also where AD lies, then the position vector P should also satisfy this line AD. So this is P. So let us check for collinearity. So if we take this D, this is 2C plus 3B by 5, and in fact if you take this is 2C plus 3B by 6. So it is quite clear that this OP is actually equal to 6 by 5. Actually OP is equal to not 6 by 5, but rather it is 5 by 6 of AD, as it is quite clear. This OP is equal to 5 by 6 of AD. 5 cancel and you get this, because this is OP and this is AD. So you say yes, this point is the point of concurrency and this is the position vector of their point of concurrency. Let us come to the next question. The next question says the vector minus I plus j minus k bisects the angle between the vector C and 3i plus 4j. Determine the unit vector along C. So here again what is given? There are two vectors. One is minus I plus j minus k, and there is another vector C, which is this one, and there is another vector 3i plus 4j, which is this one, and it says that this first vector bisects these two. So this is the angle bisector. Determine the unit vector along C. So what we have to do for angle bisector, that we take a rhombus like this, and we can in fact take this as the unit vector C and this as the unit vector 3i plus 4j by 5, and both of these are unit vectors, and the bisector would be simply resultant of these multiplied with some lambda. So bisector R will be C unit vector plus 3i plus 4j by 5. This will be the bisector, and this will be actually the resultant of these two, and this resultant is having any magnitude, and as it is saying that this is having this vector minus I plus j minus k, so we can say that minus I plus j minus k is equal to lambda times C plus 3i plus 4j, this is by 5 here, like this. We can always write like this. So this vector R vector is actually lambda times of this. Now we have to determine the unit vector C here. So if you want to find the unit vector C, what you can do, you can take it as xi plus yj plus zk. So this unit vector can be taken as xi plus yj plus zk, and you can take x plus lambda x, and lambda is multiplied to all of them. So instead of that, let us take lambda common. So let us take lambda common here. So lambda into C is x plus 3 by 5 I cap, y plus 4 by 5 j cap plus z k cap. Now if you equate them, what you get is minus 1 is equal to lambda into x plus 3 by 5, 1 is equal to lambda into y plus 4 by 5, and minus 1 is equal to lambda into z. This is how we can write it. And the third result we have is that C is a unit vector. So x square plus y square plus z square is equal to 1. So from here now we proceed. So I am erasing all this of the parts which we have utilized. So what we have done till now, we have taken the resultant vector and we have equated to lambda times of the given resultant vector, which is the bisector of these two vectors. Now after that, we have assumed that the C vector is xi yj plus zk. Now after knowing this, we also know that x square plus y square plus z square is equal to 1. So from here now we proceed, and when we proceed here, we found x square as minus 1 by lambda minus 3 by 5 whole square, then plus 1 by lambda minus 4 by 5 whole square, and then minus 1 by lambda whole square is equal to 1. So when we expand them, we get 1 by lambda square, 1 by lambda square, 1 by lambda square, that will be 3 by lambda square. Then we have here 6 by 5 lambda from here. From here we will get minus 8 by 5 lambda, so that will be minus 2 by 5 lambda. So this will be minus 2 by 5 lambda, right? And then we have constant 9 by 25 plus 16 by 25. So that will be 25 by 25. That will be 1. And that will be equal to 1. So it will be 0. So what we are getting is 1 by lambda into 3 by lambda minus 3 by 5 is equal to 0. Now 1 by lambda cannot be equal to 0. So we take 3 by lambda minus 2 by 5. This is actually 2 by 5, not 3 by 5. This is 2 by 5. So 3 by lambda minus 2 by 5 equal to 0. So from here we get 3 by lambda is equal to 2 by 5. So lambda is equal to 15 by 2. After getting lambda is equal to 15 by 2, we put here and we get the value of x, y and z. So I am remaining part, leaving it to you because we have got lambda. So after getting lambda as the answer, we come to this portion, and in this portion we put lambda and we get x, y and z, and that will give you the unit vector c. So students, that is all for the lecture here, and thank you.